Okay, let's dive into this. Welcome to today's Explainer. We're going to unpack the incredible, basically invisible, infrastructure that literally powers our entire modern world. You know, when most of us think about building a massive skyscraper, we picture steel beams, deep concrete foundations, and, well, thousands of blueprints. But what if I told you that building software is exactly the same? Seriously, it requires the exact same level of architectural precision, structural integrity, and rigorous engineering. So today, we're exploring the true fundamentals of software engineering.
To guide us, here's our roadmap for the journey. We're kicking things off with way more than just code, then moving into the engineer's ethical code, checking out the traits of great software, and wrapping up with a practical step-by-step look at the software development lifecycle.
All right, Section 1, way more than just code, uncovering the software ecosystem. Let's get right into it.
So I want to start by challenging a super common myth about what software engineers actually do all day. If you stopped someone on the street right now and asked, hey, what is software? They'd probably tell you it's just a bunch of code typed by some lone hacker in a dark basement, right? Well, I want you to completely reconsider that assumption. Coding is actually just one small piece of a much, much larger and highly organized puzzle. True software engineering defines software as a triad. It's not just instructions, the executable programs that actually tell the computer what to do. It also absolutely requires data structures to properly manipulate and organize that information. And, critically, it needs documentation that describes its operation and use. Think of it like this. If the code is the brick and mortar of our digital skyscraper, the data structures are the plumbing and electrical wiring. And the documentation? That's the architectural blueprint, ensuring future builders know exactly how the whole shebang was put together. And once you combine those three elements to meet a specific requirement, you get a software product. But here's the thing. A product isn't just created and then forgotten about. No! It branches out into a living, breathing ecosystem. It's constantly surrounded by maintenance, really rigorous testing, complex deployment protocols, and ongoing system analysis. It basically acts as both a product delivering potential and the vehicle supporting the system's functionality. Now, this ecosystem stretches across a vast array of domains that touch, well, literally every single aspect of your everyday life. We aren't just talking about system software like your computer's operating system, or standard web applications like Uber or Amazon. We're talking about heavy-duty engineering software used for astronomy and embedded software. Think about the specialized firmware controlling the keypad on your microwave, or the digital functions in your car. Oh, and of course, artificial intelligence, simulating human reasoning. Whether it's heating up your leftover pizza or driving a robotic assembly line, it all requires rigorous, disciplined engineering. Which brings us to Section 2, the engineer's ethical code, building with integrity. Okay, so we've established the technical demands, right? But there is a really profound human element here too. Just like a civil engineer wouldn't build a bridge out of cardboard, a software engineer needs a rock-solid moral foundation. What's really interesting here is how heavily the entire field relies on trust and human integrity across four main pillars. First, confidentiality, meaning you protect client secrets. Second, competence, so you never accept work outside your actual skill level. Third, protecting intellectual property. And finally, avoiding computer misuse. And that ranges from the severe stuff, like spreading malware, to simply slacking off and playing video games on your employer's dime. The source material actually puts it perfectly. It says, you must also behave in an ethical and morally responsible way if you are to be respected as a professional engineer. I love that. It's a profound reminder. Your technical skills, your ability to write the most elegant code in the world, they mean absolutely nothing if you lack professional responsibility.
Let's move to our next stop and see how this builds. Section 3, traits of great software, the standards of quality. That ethical obligation to do good work we just talked about, well, it naturally translates into tangible quality standards. To measure quality, engineers group attributes into three core categories: operational, transitional, and maintenance. A well-engineered digital skyscraper has to hit marks across the board. Operationally, it must be secure, dependable, and user-friendly. Transition-wise, it needs to be portable and adaptable to new systems. And for maintenance, it must be modular and highly scalable. The best way to really understand this is by looking at the timeline of the software. Operational attributes are all about what the software does right now, today, in its current environment. Is it efficient? Is it safe? Transitional and maintenance attributes, on the flip side, are all about how the software adapts to the future. Remember that word scalability? That is exactly like pouring a deeper, stronger foundation for a building today just so you have the ability to safely add 5 more floors to it 10 years from now.
So, the absolutely crucial point here is that form must fit function. The attributes you prioritize depend entirely on what you're actually building. For example, a banking application, its primary directive has to be high security and dependability, for sure. But if you're engineering a gaming application, interactivity and responsiveness absolutely take the front seat. And what about a telephone switching system? Ultimate, unbreakable reliability is the goal. Moving on to our final piece of the puzzle. Section 4, the software development lifecycle, the construction blueprint.
Now that we know what we're building and the strict standards we have to uphold, how do we actually pull it off? Well, to avoid the utter chaos of poorly made software, engineers use a master timeline, the SDLC, or Software Development Lifecycle. And this brilliantly illustrates the sheer scope of the sequence. It's a highly defined 11-stage structural sequence. It's not just a suggestion, guys. It's a rigorous engineering pathway.
We can basically break this cycle down into 2 main phases. Phase 1 is planning and design. This includes communication, so getting the user request, requirement gathering, a feasibility study to make sure it makes sense financially and technically, system analysis, and finally software design, where the logical and physical diagrams are mapped out. Notice something incredible here. These first 5 steps, they are entirely prep work. It is exactly like an architect drawing blueprints, interviewing the client, and surveying the land. All of this intense labor happens before a single line of code is ever typed out.
Then we jump right into Phase 2, execution and beyond. This is the actual construction and eventually the demolition of our digital building. We start with coding, translating those designs into error-free programs. Then comes testing, integration with outer world databases, and implementation, which is just installing it for the user. But wait, it doesn't stop there. We have operations and maintenance to fix bugs over time, and finally, step 11, disposition. This is when the software becomes obsolete and engineers must safely archive the data and retire the system. The cycle accounts for the entire lifespan of the product from birth to death.
Now, I want to highlight one particular step in that cycle really quickly: testing. An estimated 50% of the entire software development process should be dedicated purely to testing. Half of the effort. Just let that sink in. Why? Because in engineering, early discovery of errors is the ultimate key to reliability. Finding a flaw while you're still pouring the concrete is infinitely cheaper and safer than finding it after the skyscraper is fully occupied.
So as we've seen, software engineering is a massive, highly disciplined, and profoundly ethical pursuit. It transforms abstract ideas into the invisible structures that quite literally run our civilization, from the AI in a state-of-the-art robotics lab to the embedded chips right there in your kitchen appliances. So knowing that these are the rigorous engineering blueprints powering our modern world, the only question left to ask is, what will you build next? Thank you so much for joining me for this explainer. I really hope it gave you a powerful new lens through which to view the digital world around you.